everyone. In this video, we're going to learn how to add, subtract, multiply, and divide complex numbers. So for addition and subtraction, it might be what you assume it would be. Since a complex number is made up of a real and an imaginary component, we have what you might think of as like terms. So we actually are going to add like terms. So I'm going to add the real components. So that would add up to -3. And then add the imaginary components. In this case, that would be 5i. And my resulting answer is a new complex number, where the real part is -3 and the imaginary part is 5i. In the next example, we're just going to change from addition to subtraction. Since addition and subtraction is really the same type of operation, just with negative numbers, we're still going to combine our like terms. However, I suggest that you think of distributing this negative sign before doing so, and really turn it into an addition problem. So we still have a 2 plus 3i minus 4 plus 5i. Now let's combine our like terms. 2 and -4 are the real components. They're going to combine to -2. The 3i and the 5i are the imaginary components. They will combine to positive 8i. So our new answer is -2 plus 8i. Before we actually do a multiplication problem, you're going to have to know what I squared is equal to. Now remember that I is equal to the square root of -1. So I squared would be the square of the root of -1. Since squaring and square rooting are inverse operations, that means they undo each other, and we would just be left with the -1. So anytime we see an I squared, we're going to replace that with a -1. Now that seems kind of weird. An imaginary number, when we squared it, turned out to be a real number. Let's see what else is going to happen in these examples. So when we multiply these, I want you to think about FOIL. Okay, we're going to really do 4 little mini multiplication problems. So to begin with, we're going to multiply 2 and 5 to get 10. Then 2 and -2i for a -4i. Then the 3i and 5 for a positive 15i. And then lastly, 3i and -2i multiply to -6i squared. So that's where that I squared is coming from. So like I said, anytime we see an I squared, we're going to replace that with a -1. Right there. So really that's a -6 times -1. But we still have our 10. Oh, and we have some like terms here, right? -4i and 15i. They all combine to a positive 11i. Okay, now let's do some more simplifying. So we have a -6 times -1. That becomes a positive 6. And we still have the 10 plus 11i up here. Now we have more like terms. The 10 and the 6 are going to add together to 16. And then we have our positive 11i. So when you multiply two complex numbers, the result should be a complex number. As so. Let's do this one. Ooh, this one looks kind of interesting. Notice it's almost the same number, except the sign in between the real and the imaginary part is different. Okay? These are called conjugates. Okay? And I'm going to explain more about that in the division problem. So let's do our multiplication. 2 times 2 is 4. 2 times -3i is -6i. 3 times positive 2 is positive 6i. And 3i times negative 3i is negative 9i squared. Okay, so let's combine our like terms here. Negative 6i and positive 6i, when they add together, they get 0, so that cancels out. So we have 4 minus 9. Oh, and instead of writing I squared, let's replace that with a negative 1. So I really have 4 plus 9, which is 13. So it looks like when we multiply conjugates, we are going to wind up with just the real part of a complex number. Okay, remember that. If you're ever multiplying conjugates and you get an imaginary part to your answer, something must be wrong. So let's talk more about this idea of a conjugate. When you're doing a division problem, okay, you're going to need to know what the conjugate of the denominator is. So that was a lot of words there. Let's go through that again. Remember that the denominator is the bottom part of a fraction. When you're doing division with complex numbers, you're actually going to do a multiplication problem. That sounds really weird. So we're going to multiply this fraction by 1. Now I'm not going to write that as 1 over 1. I'm going to write it as something over itself. Okay? And like I said, I'm going to multiply, let me write this down, multiply by the conjugate of the denominator over itself. So the conjugate of the denominator is going to be 1 plus 2i, and over itself, we'll write that again, 1 plus 2i. Okay, so a conjugate has the same real part, but the opposite sign on the imaginary part. All right, so now let's do some multiplication. So we have to do multiplication of the two complex numbers in the top. Let's do that. We will get 2 plus 4i plus 3i plus 6i squared. So that's the top. Now let's do the bottom. 1 plus 2i minus 2i minus 4i squared. Okay, so let's do our simplifying. Up on top I have 2 plus 7i plus, oh, here I'm going to replace the I squared with a negative 1. So 6 times negative 1 over 1, oh, the 2i and the negative 2i cancel, minus 4 times negative 1. Okay, time to do some more simplifying. So here I have a 2, oh, this is going to turn into a negative 6. So 2 minus 6, that's negative 4 plus 7i, over 1 minus 4 times negative 1. That really becomes a positive 4, so that adds up to 5. So it doesn't look like we've done any division, because we still have this fraction, right? Fraction is really a division problem. But notice that in the denominator, we used to have a complex number, and now we have a real number. Okay, that's kind of the goal of division, because if you think about it, this is the same as negative 4/5 plus 7/5 I. Right, and that's a single complex number. Whereas in the original problem, we had a complex number divided by a complex number. Here we just have a complex number. Okay, so the important parts about division, you have to know what the conjugate of the denominator is, you have to remember to multiply by that over itself, because this is really another version of the number 1. Okay? Here's my number 1 for you. So that's an important part. You have to remember that I squared is really -1. And you have to remember that in the end, you better come up with a real number in the denominator. Let's do one more of those together before you try on your own problems. Okay, so we're going to multiply by the conjugate of the denominator. So that would be 2 minus 3i on both the top and the bottom. 2 minus 3i. Okay, now let's do some multiplication. So on top, oh, we just have to distribute the 4 this time. So we get 8 minus 12i. Very good. And on the bottom, we have more multiplication to do. We have 4 minus 6i plus 6i minus 9i squared. Okay, so let's simplify. Sorry if my eyes start to look like U's. Usually when you use I, it has like a curly, like italic-ness to it. Okay, so on top we still have an 8 minus 12i. On the bottom, the 6i's cancel, and we get 4 minus 9 times -1. Okay, keep going. We still have an 8 minus 12i on top, and then our bottom we get a 13. So you can leave that as your answer, or you might prefer to write it as a single complex number. So 8/13 minus 12/13 I. And we are done. So remember, you can ask many questions about this in class, but you do have to try on your own right now. Don't leave them blank. At least give each one a try, and I will see you in class.